In this video, I'm introducing you to the exciting world of 3D design using Fusion 360. If you're new to the software, don't worry, I've included a link in the description where you can find a personal or educational license. My goal is to show you that you don't need to be an expert to start designing. I'm not an expert myself, but with a bit of curiosity, research, and watching tutorials, I've gained all the confidence to create my own designs. And so can you. Right now, I'm working on a project I call the Cat Nagger, a device that uses sound to keep my cats off the countertop. Unlike other solutions that rely on water, and I think that's too physical, I've already developed the circuit prototype, and the next step is to design a case to securely hold all the components during testing. The circuit includes two boards, one speaker, one switch, and a battery. These are components we will need to fit into the case. In future videos, I'll show you how to build it and design a PCB once the testing phase is complete. You can find all the components I'm using linked in the description. If you're interested in following this project and others like this, don't forget to subscribe to my channel. I will post updates and tutorials to help you dive into 3D design and bring your own ideas to life, so please subscribe to the video. Here's what we will cover in this video. First, I will measure the components and write down the dimensions. Then, I will show you how to translate those measurements into Fusion 360 to create your own model. While it is true that you can find sometimes pre-made models online, I think it is incredibly useful to learn how to create your own, especially when you only need certain details for your design. By walking you through my process, I hope to make 3D design feel more approachable and give you the confidence to start designing your own projects. So let's jump in and start with the first board.
Okay, before jumping into designing, let's get familiarized with Fusion 360. So whenever you open Fusion 360, you will see this user interface. If we go to Home, you will have the options here to open a file, to open a recent file, or to create a new design. So your design could be like a normal design or an electronics design. Electronics library, I haven't used electronics library. And in the next videos, I'm going to show you how to use electronics design as well, because I'm also working on that. If we come back here, you will find the untitled file. Then whenever you open Fusion 360, you will get this file hasn't been saved in the cloud. So here is the thing. Your files are not being stored locally. Your files are going to be stored in the cloud, in Fusion 360 Cloud. I don't know how to store them locally. And that if you don't feel comfortable with your files being stored in the cloud, I think you will need to explore that yourself later. Okay, so to present you the user interface, I can split it in 4 parts: the top bar, the left sidebar, the bottom bar, and the orbit cube. So the top bar contains all the tools that you will need to modify your design. The sidebar in the left, you will find the document settings, your views or origins. Also, you will find your sketches, your solids, and your constructs. All of those are the components that constitute your design. Maybe there are more. Those are the only ones that I often use. In the bottom bar, you will find a timeline where all the changes that you make to your design are going to be stacked. You can navigate through them with this indicator. Here, also you will find like a navigation little bar. You don't really need to use that very often. I don't use it very often. And I will show you some commands to navigate through your design. And the orbit cube is also gonna help you a lot to navigate through your design. To orbit your design, you have two options. You can use the cube, or you can use Shift and press the scroll wheel in your mouse, and you will be able to orbit. And if you want to pan the view, if you want to move the view around, you can just press the scroll bar. If you see the little hand here activated when I press the scroll wheel in my mouse, so that means I'm panning. So that's why I don't use this little bar too much in the bottom, because I can navigate with the mouse very comfortable. Okay, so I'm gonna start designing. The measurements that I'm gonna use are these, the ones that I took of my circuit board. Okay, so let's start in the top view. I want to navigate to my top view. I'm gonna sketch a rectangle. So when I press on create a sketch, it's asking me of what plane I want to use to create my sketch on. If you orbit a little bit, you will see that I have the option. It's highlighting the planes, the plane on Y, the plane on X, the plane on Z. So since I'm gonna use the top, I'm gonna use Y and X, the plane that is on Y and X. So I'm gonna select this plane now. Now I can create the sketch is already created. Now I'm gonna draw a rectangle. So I click in the origin, And if you look at this, I have two input fields, one for the height, one for the length of my rectangle. I'm gonna use 50 millimeters. Don't press enter, press tab. If you press enter, it's not gonna, well, jump into the next input, and it's just gonna leave you with 50 millimeters in the height and 120 in the length. And what I want is 70 in the length. So I press tab, and I write 70. All right, so we have our rectangle. Now here, we want to draw the holes for the screws. The holes are 1 millimeter away from the walls, and they are 2.2 millimeters of diameter. So let's do that. So how do I do that? I think the best thing to do that is to create a line of 1 millimeter here in one side, in one edge of the rectangle. 1 millimeter, very well. And then 1 millimeter. So here I kind of have like the half of a rectangle. I have two sides, two measurements that says 1 millimeter and 1 millimeter. So here I'm going to create a two-point circle. 2-point circle. Why? Because you can create a circle from the diameter and control it, setting first the center and then controlling the radius of the circle, or you can create it by 2-point circle that is actually doing the whole diameter of the circle. So geometry, basic geometry, right? 2.2. There you go. And then I'm gonna create another circle with the same measurement. I mean, this is the easiest approach that I find to make this, because this is already giving my circle 1 millimeter to be 1 millimeter away from the wall. Now I want it to be 1 millimeter away from the bottom edge of the rectangle. And to do that, now I can use the normal circle. That first you select the radius, the center, and then you open to the desired radius. There you go. Now we have a circle that is 1 millimeter away from the left wall and 1 millimeter away from the bottom wall of the device. So if I hit here and I delete this one, and I delete this one, all right, we'll have a circle that is 1 millimeter away from each wall. Okay, I don't want to do that in each corner. So what I can do is using the tool mirror. So what it does, this requires a line to work as a mirror line. We draw a line, and then we click here, we select the object, and then if you look at here, there is a dialog box, and if the first option or the first input, you need to select it and select the object that you want. Then you select the second input, and you can select all your mirror line. If you look at this, now you have mirrored the circle, so we don't need to do the same operation, the lengthy operation of finding how to make our circle again. And now we can do exactly the same, but for this little circle. So whenever you have selected the object's input, you can select as many objects you want until you select the input for the mirror line. Now I select the mirror line. I cannot select more because there should be only one mirror line. I select this is going to be replacing the previous line. So I just want to select one mirror line. And there you go. We have 4 holes for each corner. Now, if we go here to the sidebar, as I told you, now we have sketches. And this sketch, we will call it the PCB core board, because we will have many PCBs, but this is the core board. Now, from this sketch, we will create a solid. And how do we create a solid? We go to extrude. What we're going to do is extrude this drawing. There are many types. There's thin or extrude. We're going to use the normal extrude. The profiles, we're going to select the profiles. This is going to be the profile. So, for example, you have the option of selecting this little one, but I don't want that one. And you can select as many profiles as you want. Where do you want it to start? It can be from the actual plane, or there can be an offset or an object. I want it to be just from the plane. The direction, it can be one side, two sides, or symmetric. So we're going to do one side right now. The extent type, distance, or it can be to an object or through an object. The distance, for the distance, let's do 1.5 meters, I think it's the measurement. Yeah. So the measurement is 1.5 millimeters. There's an angle, no, operation, new body. We will look more into these options, but you can cut, you can intersect, but right now we are going to create a new body. So there you go. We extruded our first solid, our first body. And as I told you, here you can find your bodies of your design. Now we're going to rename it as the PC board, PC core board. Okay, the next step is going to be create the ultrasonic component. So is this one in the top left of this very bad sketch. Okay, so the thing is right next to this board. It starts right next to this board. So we will create a new sketch on the same plane as our board. Oh, I think it's not letting me. So here, we're going to use the height feature here in the sidebar. So I don't want to see this body right now. So I can just make it disappear. I can make it appear again with this little eye. There's the hide show feature. So this is very useful because now I can select the plane that I want to sketch, to create my new sketch. But I want to see the sketch for my board because that might be useful for this sketch. So okay, what you just saw is a bug. I don't know why, but the orbit gets stuck. It seems even when I'm not like clicking or using the command for orbiting, the thing gets stuck, and I need to close the software and open it again. Sorry for that. Okay, so now let's see if my sketch was created. Yes, my sketch was created. We will call it rename the sketch, and this is gonna be ultrasonic PCB. There you go. And if I want to continue working on my sketch, I click twice and I get into the sketching layout. And now you can see here, it says sketch. But if I click on finish sketch, I go outside my sketch and I go back to the general design. So for example, if I want to go back and change my PCB core board, I can go back, but if you see the new sketches disappear, it's like going back in time. If you see in the timeline, I'm going back in time and I'm modifying this first sketch I created. And by clicking twice, you get into this path of modifying this sketch. But if I click on finish sketch, I come back to the general design, to the point where I'm right now. Now, let's go and create a new rectangle in this sketch. So this rectangle should be 13.5 millimeters. I don't care about the height because this is only a reference rectangle. And now I'm going to create a new one. This one I care the height because it's the PCB depth. So it's going to be 1 millimeter, you will see, and 45 millimeters. So now we're going to get rid of this rectangle. You need to select it all. I think it's going to be better next time to use references. I think I shouldn't keep using this to do references because it can get very messy. To delete them. Okay, I can live with that line there. Oh, so I can delete it here, like that. Okay, so now I have the profile of my PCB that I'm gonna extrude later. Actually, we can now go and extrude it. So I finish the sketch and I go to extrude. I'm gonna select this profile, but now we are gonna use instead of start from the profile plane, we're gonna use offset. Why? Because the PCB is not in the same plane as the ultrasonic PCB is not in the same plane where the PCB board starts, where the PCB core board starts. It starts above. If you want to see it, I have here the thing. So if you look here, this space is an offset. So what we're trying to make is this ultrasonic PCB board. So the distance is 8 millimeters from the top of the PCB board. So from this plane should be 8 millimeters plus 1.5. So the offset should be 9.5 millimeters. So on one side, it's gonna be a new body. let's select it. Now we have it, offset 9.5. The height is 20 millimeters. So 20 millimeters. Okay, now let's see our creation. And there you go. If we show our body here, so we can actually measure the distance between the start point of our ultrasonic PCB board and the core board. So if we want to measure, we can inspect, and we can say like, okay, from this point to this line, it's 8 millimeters. So it's correct. Now let's create the eyes of the ultrasonic sensor. So if we look at this, we are gonna create the eyes. If I know that you will not be able to read it, but here it says like 2.1 from each side and 2 millimeters from the top. So that's enough. Those are coordinates enough to be able to create the sketch for the ultrasonic eyes. So we're going to create a new sketch with the sketch tool, and we're going to choose the face of our ultrasonic board. So you can create sketches on planes, for example, in the axis, the one that you see here, or on anything that is plane, like a face. But the condition is that it needs to be plane. Okay. So now we have a sketch here. We will call it ultrasonic sensors. Here we will create a reference line that of 2.1. Oh, sorry, I think it's 2 millimeters, and another line of 2.1 millimeters. I don't know if you have seen. Now I'm going to explain you about snapping to the axis. If you see, like if I do it slowly, you will see that whenever you pass through the axis, through the x-axis, no, to the y-axis now, like kind of like gets like the cursor gets pulled to the axis. That's not, it's snapping to the axis. So that's very useful. You will find it quite intuitive as you design, as you get further with designing. This is one way of snapping. I will show you another way of snapping later. But right now, like the measurement of my line is locked to 2.1, and I'm gonna get snapped to the y-axis. All right. So now we have our reference file, our reference line in the coordinate 2 and 2.1 from the corner of my ultrasonic board. Now I'm gonna create a 2-point circle again. I'm gonna kind of do the same operation that I did previously. So now I'm gonna create a 15.7 circle. Oh, 15.7 millimeters diameter circle. There you go. And now I'm gonna create another one. And now I'm gonna show you another way of snapping. So if you pass the cursor close to the center, it kind of snaps to the center. And now we're gonna take it as a reference to snap to the same axis on the x-axis to create the next point for the center of my next circle. So if you slowly move towards the right, that is where I want to set the center of my next circle, you will see, like, if you try to not get very far away from that axis, it kind of like snaps to the axis and pulls the reference towards where you want it. So if you carefully, you need to be also very careful, but if you carefully pull these towards where you want your point, eventually you can intersect with your circle, and this is snapping to the axis as well. And now we can go back and create our circle. So now we have our circle that is 2 millimeters away from the left wall of the ultrasonic board, and is 2.1 millimeters away from the top edge. So now the only thing that we need to do is our beloved mirror operation. So, so we select the object, mirror. There you go. There you go. Now we have the sketches for my sensors in the ultrasonic board. Now I'm gonna pull them. I'm gonna pull them 20.1 millimeters. So now I can finish the sketch and extrude both circles. So as I told you, you can select as many profiles as you want. We're gonna start from the profile plane. The direction is gonna be monodirectional, with only one direction. And now the distance is gonna be 12.1. Yeah, 12.100. It's fine. No angle, and the operation is gonna be join. Why? Because this is gonna be joined to this body. I don't need a new body. I'm okay that this is part of this body, because actually this is even a reference. So it's fine to be joined. It's gonna be only like a extension of the ultrasonic board body. So let's do a join. Okay, we press OK, and now we have our ultrasonic eyes. Now, the next step is going to be creating the holes, the screw holes, because this is going to be placed using inserts, brass inserts, and it's going to be screwed to the through the walls of the case. So we need to create those little holes for the screws. So we're going to create a new sketch. I think we can actually reuse. We're going to go back and modify this sketch. Nope. Actually, we cannot use that sketch. We need to create one sketch. Since we use the profile instead as the measurement for extruding our board, now we need to create another sketch on the same plane where we created our sensors. And it's fine. Now, instead of pulling, instead of extruding, we're gonna cut through. So we're gonna call this sketch the ultrasonic screw holes. Okay. Okay. So now we're gonna go. This is 0.6 millimeters away, and same 0.6 millimeters, 0.6 millimeters. We're gonna create another circle, another 2-point circle. This is 1.8 millimeters, and now another circle. We snap the center. We create the center. Now we have our hole. I'm gonna go quicker because this operation we have done it already 3 times. So I'm gonna mirror. Oh, to do this, I will need to create another rectangle so I can copy the references. So I go copy this, go copy this. Now it is copied to my new sketch because I'm in a different sketch. Oh, yeah, I can see it, but if but I cannot reference always. So I don't know why the reference like doesn't pass through easily. Like if you zoom out a lot, sometimes you can get some reference, but sometimes it is just better to transfer that reference by copying the rectangle. Okay, there you go. Now, there you go. Now I'm gonna mirror this one. Select line. Okay. When when the triangle, when this little triangle appears, that means that that's the center of the line. That's something I forgot to tell you before. Okay. Now select line. Okay. Oh, just let me confirm. Yeah, looks legit. Here we have the holes. Actually, now even we can get rid of the whole rectangle. No, let's not do that. So let's extrude. But now, instead of new body, we will cut. That's the important thing. Now we're select this one. We're gonna select. Oh no. I need to somehow. Interesting. What is okay? Let's hide this one. Let's hide this one. Let's hide this one. So there you go. So that's the reason why hiding is very useful. Now, how much we want to cut? I don't need to be exact. Sometimes you can just click on this arrow and pull it. How much? As much as you want, just to cut through. And there you go. And we have the holes for our screws. Sorry if the audio is not synced, but for this video I didn't record the audio because I had the microphone off. This is gonna last only 2 minutes. So the next step is gonna be extruding the reference for the inserts in the case. So what we're gonna do is gonna extrude a cylinder out of the ultrasonic sensor plane. Whenever we create the case, we already have the measurement and from the center of the circles of the screw holes of the ultrasonic sensor. So we created our new ultrasonic insert sketch. Now we are gonna draw circles using the same center of the previous circles that we created for the ultrasonic screw holes. But these ones are gonna be larger. They're gonna be 2.8 millimeters diameter. And then we are gonna mirror them. Same process as the previous holes. So we can go a little faster on this. We mirror vertically, then we mirror horizontally. Now that we have our holes, we can extrude them so we can transfer these measurements to our case whenever we create our case. So we select the profile, we select both profiles because we don't want like a floating circle, because that's what will happen if we don't select all the both profiles. So we extrude it and we have our references ready. Now we are going to create the sketch for the USB port, and we're going to extrude it so we have the reference whenever we create whenever we build our case. So now let's call this USB port. This is going to be the sketch for the USB port. We're going to create a reference rectangle of 15 by 16 millimeters. Now we're going to create another rectangle that is going to be the actual rectangle for the USB port hole in the case. That's going to be 3 by 9 millimeters. There you go. Now we have, let's get rid of our reference rectangle. Now we can extrude these so we can have the reference. So it's going to be a very simple one. The distance, let me confirm the distance. The distance is going to be 4.2 millimeters from this plane. I took that exact measurement, so that's gonna be very easy. I would do that. Sorry, it's gonna be a new body. Yeah, it's gonna be a new body. So this new body, we're gonna call it. Oh, sorry, Control Z. Useful. This body is gonna be the USB port. USB port. There you go. Now let's we have the USB port. Perfect. We have the reference for the USB port. So we can look at the device. This device. So here is the ultrasonic, kind of like push like this. And here's the USB port. So this USB port, if you look at it, it's a little off the PC board. So I want to have this reference because it's the only thing that I want to get exposed outside the case, the sensors and the USB, at least from this part of the device. Okay, now I'm gonna walk you a little through my thought process. So in this case, I don't know if you're able to see it if you zoom out in my view. So I'm showing you the sensor, and whatever you see here in the button that I'm holding is gonna be the recording board. So the recording board, if you look at closely, it has some brass separators that are gonna keep it away from the wall. So I'm gonna work on that part now. It's better because I was gonna work at first on the speaker. That is the funnest part. I think it's the most interesting part. But the thing is that the speaker is gonna be a little to the left. That is my left, your right, due to the circuit being in the right and be separated from the wall. So the speaker is not going to be exactly in the center below the ultrasonic sensor. It's going to be a little to the left. So at least at the end, I'm going to fit the speaker wherever it fits. But I think it is not going to be kind of like attached to the left or right wall. It's going to attach to the front wall. That's the only thing that I care. So the one that is going to determine how left or how right is going to be the recording device, because that one is going to be attached to the right wall. That from your perspective is going to be the left wall. Okay, so that's why I'm going to jump and work on that one. So that's how I made that decision. So whenever you design, you will find this type of not troubles, but problems to solve on you deciding which part you're gonna work next. Okay, so if we look at this, our left side, we said it's gonna be on the left side, right? Of the ultrasonic sensor. So yeah, we're gonna use the left wall. Oh, okay. So we are gonna create. I created this sketch thinking that I was gonna do the speaker, but I stopped the video. I modded the lights, and also I was like, okay, no, I'm not gonna work on the speaker. I'm gonna work on the recording device. We're gonna create a construct that is gonna be a plane where we're gonna create a sketch that is gonna have an offset from this wall of the PCB board. You will see why. You will understand better when I show you why. So the offset plane that I'm gonna create is gonna be my based plane is gonna be this wall, but the depth, the offset is gonna be, let me tell you, it's gonna be 2 centimeters. No, yeah, that's 20 millimeters. 20 millimeters. And let's see in what way. Yeah, so it's gonna be minus 20 millimeters. There you go. That's now our plane. On that plane, we will be able to create a sketch, and we now have a plane here, a construction plane that we are gonna rename as the recording device plane. On this sketch is going to be recording device. So we will want to have that device with some tolerance, like not completely next to our PC board. So it's going to be maybe, I think a good tolerance is going to be 5 millimeters away. So let's create a reference for those 5 millimeters. Let's create a line for that reference. Are we working? Let me confirm that we are working on the right sketch. Yeah, we're working on the right sketch. So we're going to use this as a reference. And we're going to 5 millimeters. There you go. Okay, so we have 5 millimeters. So I have the measurements somewhere here for that device. That device is 40. It's 20 millimeters. That I'm not sure. So I'm gonna re-measure that part of the device and soldering. So that was very weird. It's actually 38 by 42. 42.7 by 38.2. Okay, so we are gonna create a rectangle of 38.2 by 42.8. Now, we can move our rectangle to the center. So let's do the line, center line again. Center, and let's do the 5 millimeters one. Now we're gonna move the whole thing. We're gonna repeat the modify command, move. We're gonna set our pivot. Let's see if we can find the center. That's what I'm afraid of. Like, I'm not gonna find the center. If not, I will need to create a line. I'm gonna create a line. But this line is gonna be towards the other side, towards inside the square, the rectangle. Sorry. We create our reference file. We want to move this one, but not this one. Let's move. Well, let's select again. Interesting. Yeah. So it's gonna be point to point. And from this point to this point. Why didn't it happen? Point to this point. Okay. Yeah. There you go. Now we move it, and now these lines are aligned. We can get rid of them now. Sorry for that. That was quite troublesome. Now we are gonna make the holes for the screws, for the bolts. We are gonna use line that's gonna be 2 millimeters. There you go. 2 millimeters. There you go. Now we are gonna create a circle, a 2-point circle again. It's gonna be 1 point. It's gonna be 13 millimeters. So how many millimeters is gonna be? It's gonna be 3 millimeters. 3 millimeters diameter. And now we are gonna create another one. Zoom in, snap, code to the point in the circumference that intersects with our reference point. We delete the circle. Now we have a circle that is 2 millimeters away from both edges. We now can delete this. Now we can find the center point again. Now we select mirror, mirror. Okay. Now we do this again. Mirror, 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 mirror. Right. Select here. Select the objects. Object. Right. Okay. That is gonna be 1.4 deep. So the distance is gonna be 1.4. Let's see where it is going. No, I don't want to go that way. I want to be minus 1.8, 1.4 millimeters, 1.4 millimeters towards the other side, since this one is gonna be connected to the separators and then to the insert. So yeah, it has to be 1 centimeter away from the wall, from the left wall in this case. Let's measure faces. So from this to this, the distance is 20 millimeters. So I think this is wrong. So we will need to fix it. So we will need to go and modify this one. We're gonna edit this feature, and instead of 20, we are gonna 10. So if you look at the timeline, I went back, all the way back to this operation and repeat it. And now by changing this in the past, it's gonna change the feature of my whole model. Now we are gonna create the reference for the microphone and for the button. So if I show you this, if I show you the recording device right here, you will see that here are some buttons. The red button is to record, and this black little circle in the top is to record, is the microphone. So I want to expose that through the walls of the case. So I'm gonna create a circle on this sketch. I'm gonna create another sketch on this face. On this face, this is gonna be recording device cuts. Recording the reference cuts. So this is gonna give me the reference for the microphone and the button. Okay, I think I just found a problem. I think the cable is not gonna be able to reach the position that I was expecting for the horizontal recording device. So what I'm gonna do, I'm gonna rotate this sketch. So we're gonna finish this sketch for now, and we are gonna rotate it. So we're gonna rotate all these sketch, and that's not a very difficult thing to do. We can use the move command. So to do that, we need to again create reference lines. Let's create to get the center, because we want to rotate it on its center. So we're gonna select everything here. We're gonna select the center and rotate 90 degrees. Doesn't matter to what side, since it's symmetrical. Okay, I'm gonna show you something that I think is worth to mention. So if you saw nothing happened when I click OK, it's because you need to first select your pivot. Whenever you select your pivot, then you need to Fusion 360 let you select another position, a starting position for your reference. So I don't need to select right now a position. I actually haven't found a use case for this, but you need to select 0 degrees if you don't want to move it. Move the first reference, and then after setting that reference, you actually gonna give it the angle that you actually want to modify. So the steps were: you select where your pivot is gonna be, you select to enter the angle, the starting angle that you want for your pivot, that in this case is 0. I haven't used a secondary angle. And then you use the actual angle, and then you set the actual angle that you want to move your piece. So it's 3 steps: select pivot, select secondary reference angle for your pivot, and then the actual angle for your rotational over the pivot. So remember, it's kind of tricky, and sometimes you get like kind of deceived, but yeah, we were able to do the angle that we were looking for. Now we need to move it the distance, because since it was not symmetrical, well, not, yeah, it was not, the length was not the same as the height. So our space between the board and the recording device is not the same anymore. So we're gonna move it downwards. So I want to make a dimension here from this line to this line, from this point to this point. Let's just move it. So from here to here. No, we want 5 millimeters. Okay, we can delete this one. Can delete this one. Okay, so we're gonna move it downwards. So what we are gonna do is go to move. We're gonna select our square. We're gonna unselect this part of the line, this vortex of the line. We want to unselect all this line, because if not, if you try to move that, since it's anchored to something that is unselected on the command, you're just gonna rotate the square. So you want to make sure you're not selecting anything of that reference line. Okay, I was running into that problem, and I needed to repeat the thing many times. So we're gonna set the pivot here, and then we're gonna move it down. Well, no, before moving it down, we need to say done here. Done. This thing should be not selected. It shouldn't be like look selected with a check. It should look like that. If not, you're gonna be just moving around the pivot. So now we moving the object. So if you look at this. It's not snapping itself, but there you go. It snaps now. Whenever something is not snapping, you want to zoom in, and you want to zoom in a couple of times, sometimes, so you can move it as close as you can. And sometimes you zoom in so much that the tolerances within the software is just gonna take it like the actual like round up number that you want. So now we have our square 5 millimeters away from the board. Now we are gonna proceed with the hole for the microphone. So we are gonna go and edit this sketch. Now we are gonna create a line. So now we're gonna create a circle, a 2-point circle, because I want to get this the center. Well, I actually can do this with a line, right? But it's gonna be very clear. Let's try to do it with a line. If not, we do it with a circle. There you go. I have my line, and in the center of this line, since the circle is gonna be all the way down next to the right wall, the center is gonna be the half of 9.5. That I think is like 44.75 millimeters. But since I don't want to do that calculation, I can just do a line of 9.5. That is the diameter of the microphone, and let the software give me the half of it, the center of it, this, and then the microphone from the top wall is gonna be 8.6 millimeters away. Okay, so I have already my reference where my 9.5 millimeters of diameter circle is gonna start at. So I need a 2-point circle again, not a center circle. And now we just follow the y-axis. 9.5. There you go. So now we have a 9.5 circle, 9.5 diameter circle, 8.6 millimeters away from the top and next to the wall. So that's how you make the microphone. Now we are going to remove the reference lines again. No, clean up. And now we're going to create a circle of 20 millimeters of diameter. We're going to create a circle of 20 millimeters of diameter. Why? Because of the diameter of my finger. And you will say, what? So my finger is kind of like 13 millimeters of diameter, but I know that people have very thick fingers. So let's say 18 millimeters diameter. You will say, why? Because you will need to push a button to record, but the button, unfortunately, if you look at here, you need to press this button. So you need to go through the wall of the case because this thing is inside the device and it is almost 1 centimeter within the device. So you need to cross the wall, be able to press this button that is behind actually the wall, behind the plane of the wall. So you need a circle. We need to create a reference to create a circle next to this brass support to be able to push this button. So that doesn't need to be very exact. I wish. And that circle is just gonna be quite here and needs to be 18 millimeters. Hopefully that's enough. If not, well, we will need to come back and change this thing. So let's just check my finger again. What's my thickest finger? My thickest finger is 17. Let's do it 20. Let's do it 20. Let's see if this is not conflicting with anything else. It might be. Since this is already getting in the way of the wall, let's do it a little smaller and someone can use its pinky finger to press that to record. I mean, this is just a prototype, so we don't need to be very super exact. 18. I think it's still well, 18.6. Yeah, it's not passing this line. Okay, yeah. The grid works very well for these types of things. So, okay. Now we are gonna extrude, so we have those references in our walls. So we finish the sketch. We select these planes. I don't know what's kind of cutting off my circles, but it's fine. Now we are gonna pull. We need to be very precise with this. We just need to have it going out of our yeah, kind of like let's do it like this. Yeah, let's do it 16 millimeters. Yeah, there you go. So we are sure that it's gonna go through the wall. Okay. I like that. Something that I don't like is that I don't know what that circle is getting there. So we might need to translate. We will need to move it away from there. So let's modify again this sketch. I don't like that. Yeah, I don't like this. So we will move it. So again, we will move. Yeah, we're gonna move it from here. Where? X-axis. 1 millimeter. Yeah, I like that. Actually, because I'm thinking that I need wall for. Yeah, let's move it a little more. Why? Because I will have the inserts in the wall, and they require specific thickness of the wall. So I'm gonna move it a little more downwards. Let's select this again. Let's do it with 2 millimeters. I think 2 millimeters should be fine as a tolerance for the wall. There you go. We have our references for that. Now we also need the references for the inserts. So the inserts that I'm gonna use, my inserts, I'm also leaving the link in the comments for the inserts that I am using. Just let me make sure that I'm designing the correct ones. It comes with many, so I want to make sure I am using the right ones. Okay, yeah, I think I'm using the right ones. So this is the real life insert, very small. So let's go and create another sketch for the inserts. Let's create another sketch here. I'm gonna call it recording device inserts. Okay, 3.8 is fine. 3.8 is fine. 8. There you go. 3.8. And instead of doing the mirror thing, we just let's see what's faster. It's just repeating the command. Maybe it's faster. I don't know. Yeah. So that was easy to catch up. We didn't need to do the mirror, so you can see how fast it's not using the mirror as well. Okay. So I'm gonna just don't show anything else. All these bodies, we haven't named this body, so we're gonna rename it later. But right now, what's that? What's that? Okay. So I'm gonna use that one. That one. Yeah, since I use that sketch as a plane for my sketch, I think it's transferring those measurements. I hate when it does that, so it's fine. So it is gonna be 1 millimeter, and you can actually do sums here. So I'm gonna sum. You can do additions, you can do math operations there. 6 millimeters. It's 6 millimeters deep. So there you go. You can do that operation, and it's gonna give you 6 millimeters. So now we have the references. Oh, and it's creating many bodies. So let's repeat that. We're gonna edit the feature, and instead of using new body, we're gonna do join. So it doesn't create so many bodies. I don't know why it's still doing that thing. And we're gonna join. I don't know why it's doing that. We should be able to edit that feature. Join. Yeah, it should be 16 millimeters. Okay, yeah, it's also it should be 10 because this is 1 centimeter. No, just let me make sure there's 1 centimeter. It's 10 plus 6 because the brass support. There you go. So instead of creating 4 new bodies, I just join them to this big body, and we're gonna rename it as the recording device. Yeah. So you go. Now we can show the rest of our devices. Yeah. So are you ready for the most exciting part? I don't know why, but I just like the speaker. This is gonna be fun. Also because of the operations that we're gonna make, it's gonna make it quite fun. So okay, so let's take a look to the device. So now we have the recording device, as I told you, like occupying a part of the left side. So it is not gonna let us center the speaker right below the ultrasonic device. So okay, so the plane that we are gonna use is this one. Why? Because from here, the wall is gonna be matching. The wall of the case is gonna be matching this wall, kind of. Well, that's our hope. Actually, what I just told you is incorrect. You know why? Because I didn't realize that the ultrasonic device has this oscillator right there. So I will need to add some support to the design. So the inserts are gonna be a little separated, so it allows to the wall be avoiding. Yeah, it's gonna allow the the wall of the case to avoid the oscillator of the ultrasonic device. So that's a huge issue. But that's how Rob, what was his name? Bob Ross would say it's a happy mistake. Yep. I'm gonna use a 6mm support. That is, I think it's not called support. I think it's called separator, and that's gonna help us to avoid that ugly oscillator. There you go. Now this is how it's gonna look like. This is separating, so allowing space for the oscillator. And how we are gonna fix this? So there's a feature. We are gonna go to our timeline, and we're gonna search for those references to those volumes to highlight, and yep, those are the ones that are highlighting. So we're gonna configure this. Oh, okay, no, I don't know why. No, not configure. Oh, sorry. So we are gonna edit the feature. We're gonna edit the feature instead of 4.2. Now we are gonna need 4.2 plus the new, I think, is 6mm. Yep, it's 6. It's 4.2 plus 6. So we can actually do this plus 6. So now we go with the feature. We confirm 4.2 plus 6. Yeah, excellent. So let's see. Still, maybe it's not gonna look good. Yeah, there should be an issue. So now we can come back to where we left it. And now we were doing the sketch for the oh well, now that's gonna, this impacts this new thing. Why? Because now the wall is gonna be 6mm with a 6mm offset from the wall of the ultrasonic, from the face of the ultrasonic sensor. So we are gonna create a construct from here. Distance, well, it's gonna be the distance 6mm because it's 6mm of separation. There you go. We have 6mm of separation here. Now we can use this plane to create. Well, let's name this plane. Let's call it speakers. Let's call it front wall inner plane. But it is what actually that's what it is. Now we're gonna create this plane. I want to show you. So now we have our sketch here. If I'm not wrong. Yep. We're gonna call it a speaker sketch. Okay. Let's decide how far we want our speaker to be from the walls. So the whole diameter of the speaker, I actually have the drawing here. If you want to pause the video and check it and check it better, you can do it. So we have 50 centimeters of diameter. So 57mm of diameter. So we want to have that maybe 5mm away from, maybe not even 5, because it has some tabs where the screws go. So if we look at it, you will see that those are the tabs where the bolts, how it's mounted. So like the mounting tabs. So those mounting tabs are kind of like they're like 7mm. So let's say 8mm away. So let's say 8mm. Okay, it's not visible. You are completely right. Yeah, that was a very good warning. Okay, this is not getting me the reference. Interesting. No reference. Let's try. Let's see if it gives me the corner. Yeah, it gives me the corner. 8mm. So again, the circle should be right there. So actually, we can use the trim tool to delete the lines that we don't need. So this is exactly the point where I want my circle to start. So let's create a 2-point circle again from here. Hmm. 57mm. And again, now we can create a normal circle. Here. You see. So now there we have a circle for our speaker 8mm away from each of these. But if you look at this, I'm a little worried that this is kind of like getting very outside. from the PC board, like very off from the PC board. It's fine. We're gonna keep going, and let's see. Once we finish the tabs, the mounting tabs, that is gonna be very fun to make them. Maybe after that, maybe we can fit it closer to the recording device so it doesn't like goes way off. Let's see how that goes. So now we are gonna create a line of 34 millimeters that touches again the circumferences in some point. And wherever it touches the circumference, that's the 34 millimeters of distance that I wanted, that I actually was able to measure. Maybe I'm doing this very complicated, but that's the only way that I found how to get these measurements with only a liner. Sorry, with a caliper. So I didn't know, like that's only what I had, and I needed to get the distance between the tabs. So that's the only way that I found it. So I have the distance that I want from this corner to this corner. Okay, so we are gonna now remove this line, and we're gonna create a line. So the little square for the mounting tab is 7 by 7, around that number. So it's 7, and since it's a I don't know how you call it, like tangent plane. It's gonna be a little complicated. Let's see if we can figure it out. So we create a tangent line, well, like an intersecting line in 2 points of the circumference, and now we create a parallel line. So how do we create a parallel line? We can choose this. Oh no, let me see. I don't know what you're doing. Only this line. There you go. We create a parallel line with offset. So we create an offset line of 7 millimeters. There you go. So there should be 7 millimeters between this point and this point, from this point and this point. So with that said, now we can close it. Nice. Completely nice. And there you go. We have our line. Actually, we can even trim these lines because now they are part of the circle. Now we have the 7 by 7 square. Now we need to create a 3.4 millimeter circle that is 2.2 millimeters away from the end of the tab. So we are gonna create a measurement. It needs to be parallel. How do we do that? Let's try to do something. From here, we're gonna create a 2 point. No, this should be 4.4 because 2.2 by 2, because the radius, because this is the diameter, right? And we are interested in the radius. So the radius is 2.2, but by 2 because the radius the diameter is 2 times the radius. So we have 4.4. Now we can create a line, a parallel line, another offset line. This line, we can create an offset line that is 3.5 millimeters. Why? Because 7 divided by 2 is 3.5 millimeters. But let's do it to this line. Well, it's going to be minus 3.5, right? Okay. So here you go. Now we can create a circle of 2 points over this line. How much it was? 3.4. Of 3.4 millimeters. 3.4 millimeters. There you go. So yeah, a lot of magic, a lot of witchcraft here. But now we have, if we go and measure what's the distance? 2.2 millimeters, that's what we wanted. And this circle is 3.4, so we have the 2.2, the 2.4, and I think we are okay with that. Now, what we want to do, okay, so what we can do, we want to copy this tab, this mounting tab here. So how do we do that? So we will need to measure an angle by creating 2 reference lines. We create this reference line. We create this reference line. What we want to do is to get the angle between these 2 lines. So we say we can get the angle between this line and this line. The angle is 59.13 degrees. So let's write this down. 59.13 degrees. So what we are gonna do is translate my tab, the one that I already have. We're gonna copy it and translate that copy 59.13 degrees. So now we go, we move, we copy, we set pivot. The pivot we're gonna set here. Now we're gonna use that preset feature of the pivot. Let's put it right here. Let's put the 0 here. And now let's do, let's just start doing it. So it's the Z angle, and we're gonna put 39.13. Oh, that's the point. And that's exactly where we need it. There you go. Now the distance between these corners is 34. Now we can do a trimming here. Fine. Okay. I don't know why it showed that. I think it's fine. Now, this is very nice, but now I want this to be horizontal. So this is kind of diagonal. So I want to like translate it, rotate it to be horizontal. To do that, we can create another reference line between these two. If you look at this, it's going to give me the half of this line. That's a very nice feature. And we can create a line here. And we will measure again. We will measure the angle here, and it's 36.619 degrees. So let's write this down, 36.619 degrees. So we can remove these, we can select all these, we can modify, we set the pivot here, we set the 0 right here, and now on Z, we're going to translate it minus 36619. Let's see what happens. Yeah, there you go. We got it. Kind of looks horizontal to me. Now we are going to copy. Now we are doing another mirror. So we will make a line right here. We now select this, and we're doing mirror over this line. And we mirror the mounting tabs. We just need to do the trimming because the trimming is not being copied. You cannot mirror the trimming, I think. And I think we have our references for the speaker. So now this is the actual like template for the speaker. But what we actually care of is the reference, the reference lines for the cutting of the case. So we are gonna create a circle here. And now this is gonna be the circle for exposing the speaker. And now we need the one for the inserts. The inserts, we are gonna use the same inserts that we use for the recording device. So it's 3.8. So the diameter is 3.8. So we're gonna do 3.8. Ooh, okay. So I think it's fine. 3.8. 3.8. I mean, this is gonna be a little awful. 3.8 because I will need to select the center and the inner circle and the outer circle. It's fine. We said that we might be able to translate this a little to the right, so we avoid to create so much material only because of these two mounting tabs. So what we can do, maybe we can rotate 90 degrees and move it towards right. That might be an approach that it might be worth to try. I think so. So let's do that. Let's rotate it 90 degrees. We don't need these reference lines anymore. So we might be able to rotate this. Let's rotate this thing. Oh, okay. We can maybe rotate all these to make it fit better. We here, we rotate 90 degrees. Nice. Okay, we might be able to move it 5 millimeters here. Then maybe what do you say? 6 millimeters now. I think it looks away better. Maybe 6.2 millimeters. So this line is being touched by 6.4 millimeters. This line is still being touched 5 millimeters. There you go. I think this it's gonna definitely work way better. So I think it fits better like this. And even maybe we can, no, I think it is fine because we also need space for the battery. So right now we are gonna just extrude the, let's extrude the speaker back and its references. In the sketch, let's extrude the whole speaker. Let's just say 1 millimeter back. Just as a template, minus 1. No, just minus 20. There you go. Let's say that that's the speaker. There you go. It doesn't collide. And we can actually extrude the references. It's showing it. This is gonna be 6. It's gonna be 6 millimeters. 6 millimeters. Okay. Well, actually, let's repeat this. Let's edit this feature and remove this one. I only want the insert for that one, and I'm gonna extrude separately this one. I want this one to be maybe 6. It's gonna be 6 thickness. Maybe let's do it 8 millimeters. It's gonna be joined as well. It's gonna be joined to the main body. So this whole body is gonna be the speaker. Now we are gonna create the battery. This is gonna be fun as well. The battery is 38 millimeters by 20 millimeters. So, and I think the battery is better if it is attached to the back. I think the battery is gonna be better if we set it right next to the back wall. So we're gonna use this as our plane for this sketch. I'll call it rename battery. So I'm gonna create 20, no, 38 by 20 rectangle. You see, we're gonna translate these maybe a couple of centimeters down. Let's just make sure that the speaker has the thickness that I think it has. So let's go back to the speaker. Why? Because I don't want the battery to collide with the speaker. So let's have the real thickness of the speaker. Speaker is 22.8. 20, let's say 24 millimeters. So minus 24 millimeters. There you go. Yeah, I don't think it's gonna collide. So we have our battery. Actually, we can just go and extrude our battery before moving it. Let's extrude our battery. So we say that is like this one. I think we said that is 7.4. So it's 4 millimeters. Oh, it was that. Okay, but it's minus towards the other side. Oh no, join no. It is a new body. I don't want it to be joined to anything that it touches. So let's call it rename battery. So this is the battery. Okay, so we are gonna go back in time and we're gonna modify this sketch. Let's edit this sketch. So we're gonna select this. You can also do right click on what you want to change. Let's set the pivot here. Y distance, let's say. Yeah. So I want to move this, I want to move this. Okay, so I'm gonna select what I want to move again because I don't know what happened. So let's select this, select this. So I think the pivot is good here. Now there's something that doesn't want to get moved. So let's figure out what doesn't want to get moved. So let's select again. Let's try to move this one. Okay, yeah. No. 1, could move, yeah, we could move this way, but I think there is a constraint somewhere here. So let's see how we can fix that. We can eliminate this line. We can eliminate this line. We can move this one, and we can create a new line. Maybe. Okay, now let's move this. Move. Let's set the pivot somewhere here. Done. Now we can move it. Let's say I want it right here. Maybe somewhere in the center here. I think it's fine. Yep. So the memory now I can close this and see. Let's see what happened with the next. Yeah, actually we went back and we went back to the past, then back to the future, and we achieved what we wanted to do. Now there's again the bug with the orbit. Now I read in the internet that if you take the corner of the orbit cube and you pull it to the center, the bug gets fixed, and actually it worked. So now if you want to get that bug fixed, you can also follow that the trick, and it fixed that bug. So remember, click on the corner of the box and pull towards the center of the screen. So that's how you fix the problem with the orbit cube.